Most catastrophic engine failures happen because drivers ignore basic maintenance principles. After pushing my truck past 700,000 miles, I've learned that engines don't randomly die. Bad habits kill them. These 13 simple practices can transform how long your vehicle lasts, even if it already has some issues. Oil companies and dealerships push 10,000 to 15,000 mile intervals with synthetic oil, but that's pure marketing designed to boost their profits. Real-world driving conditions demand a different approach. For brand new engines, schedule your first oil change at 1,000 miles. This crucial step removes metal particles and manufacturing debris left over from the break-in process. After that initial change, stick to 3,000 to 5,000 mile intervals, or every 6 months, whichever comes first. When changing oil yourself, always inspect the filter by cutting it open and examining the pleats for metal particles. Shine a flashlight into the drain pan and look for metallic shimmer. This indicates internal wear has begun. These simple checks reveal engine health better than any lab analysis or synthetic oil promises. Thick, tar-like sludge builds up when oil changes get delayed too long. Following the 5,000-mile rule prevents expensive repairs that cost thousands of dollars down the road. Selecting the right oil matters just as much as changing it regularly. Many drivers grab whatever's cheapest, but engines are designed for specific viscosity ratings that directly affect performance and longevity. Oil ratings like 5W-30 aren't random numbers. The first number, 5W, indicates how the oil flows in cold temperatures. Lower numbers mean thinner oil that circulates faster during cold starts. The second number, 30, represents thickness at operating temperature. Using 10W-40 when your manual specifies 5W-30 stresses the oil pump and disrupts proper flow rates. Conventional oil costs less, but breaks down faster under heat and stress. Full synthetic oil resists thermal breakdown, flows better in extreme temperatures, and protects modern engines with turbochargers or direct injection systems. Synthetic blends offer middle ground protection, but aren't ideal for long-term durability. Always check your owner's manual for the exact specification. Using the wrong viscosity doesn't just hurt performance, it accelerates engine wear and can void warranty coverage. Small oil leaks turn into major problems faster than most people realize. That tiny drip under your car represents a ticking time bomb that can destroy expensive components. Oil leaks damage more than just driveways. Leaking oil soaks timing belts, causing them to slip and potentially bend valves in interference engines. Hot oil dripping onto exhaust components creates fire hazards. Leaked oil also contaminates oxygen sensors, degrades rubber belts, and corrodes electrical connections. Modern engines naturally consume some oil, especially turbocharged models. Combine normal consumption with an ignored leak, and oil levels drop dangerously low before warning lights activate. By then, internal damage may have already occurred. Regularly inspect your engine bay with a flashlight, looking for wet spots, crusty buildup, or the smell of burning oil. These early warning signs cost far less to address than replacing an entire engine. Jumping into your car and immediately driving aggressively causes significant engine damage. Cold starts account for roughly 90% of engine wear because thick, cold oil takes time to circulate throughout the system. Until oil reaches all moving parts, metal components grind against each other without proper lubrication. Pistons, camshafts, and bearings suffer the most during this vulnerable period. Turbocharged engines face even greater risks since their turbines spin at extremely high speeds and depend on immediate oil pressure. Allow your engine to idle for 30 to 60 seconds before driving. During the first 5 to 10 minutes of driving, keep RPMs low and avoid heavy acceleration or high loads. This gentle approach allows oil, coolant, and transmission fluid to reach optimal operating temperatures gradually. While warming up prevents cold start damage, excessive idling creates different problems. Extended idling prevents engines from reaching optimal operating temperatures, leading to incomplete fuel combustion and carbon buildup on intake valves and combustion chambers. Direct injection engines in many Ford, Hyundai, and Volkswagen models are particularly susceptible to carbon accumulation during long idle periods. This buildup requires expensive cleaning services that can cost $500 to $1,200. Long idle times also reduce oil pressure, starving upper engine components like camshafts and lifters of adequate lubrication. This causes premature wear and sludge formation over time. Remote starters don't need to run for 20 minutes in winter, and summer air conditioning doesn't require extended idling. Start the engine, idle briefly, then drive gently until everything reaches proper temperature. The positive crankcase ventilation valve costs around $10, but can cause thousands in damage when neglected. This small component vents pressure and blow-by gases from the crankcase back to the intake system for combustion. Clogged PCV valves create excessive crankcase pressure that forces oil past seals and gaskets. This pressure can crack valve covers, blow out rear main seals, and foul spark plugs. Stuck open valves create vacuum leaks that cause rough idling and oil consumption issues. Replace the PCV valve every 30,000 to 50,000 miles, or sooner if you frequently drive short distances. The replacement process typically takes 5 to 15 minutes on most vehicles and provides excellent insurance against expensive repairs. A dirty mass airflow sensor throws off the engine's air-fuel mixture, causing sluggish performance, rough idling, and poor fuel economy. This sensor tells the engine computer how much air enters the system so it can deliver the correct amount of fuel. Dust, oil vapors, and general grime accumulate on the sensor over time, skewing its readings. Many drivers replace expensive components like spark plugs, ignition coils, and fuel injectors when a simple sensor cleaning would solve the problem. Use only dedicated MAF sensor cleaner, never brake cleaner or carburetor spray, which can damage sensitive components. Remove the sensor, spray it gently, allow it to air dry completely, then reinstall. Avoid touching the delicate sensor wires during this process. Clean the MAF sensor every 12 months or 15,000 miles, especially in dusty environments or when using oiled air filters. Engines need clean air, just like humans need clean oxygen. Clogged or poor quality air filters restrict airflow, reduce performance, and upset the fuel-air mixture that affects economy and emissions. Bargain basement filters don't seal properly, allowing dust and sand to enter the engine. These abrasive particles wear down piston rings and cylinder walls over time. Some filters are so poorly made that rodents can nest inside the airbox, causing extensive damage. Stick to reputable brands like OEM filters, WIX, Fram Ultra, properly maintained K&N, or Bosch. Replace filters every 15,000 to 30,000 miles or sooner in dusty conditions. Hold used filters up to light. If you can't see through them, they need replacement. Spark plugs control combustion timing, burn efficiency, and emissions output. Cheap, no-name plugs cause misfires, poor fuel economy, and long-term engine damage that far exceeds their small savings. Quality spark plugs from NGK, Denso, or OEM suppliers ensure proper combustion under all conditions. Modern engines typically require platinum or iridium-tipped plugs that last 60,000 to 100,000 miles while maintaining consistent performance. Always gap plugs to manufacturer specifications unless they come pre-gapped from the factory. Avoid questionable brands that may cause misfires, trigger check engine lights, or damage catalytic converters and ignition coils. The check engine light warns of problems that can escalate into major failures. Ignoring this warning often turns minor issues into expensive disasters. Common diagnostic codes include P0171/P0174 for lean running conditions, P0300 to P0308 for misfires, P0420 for catalytic converter efficiency, and P0440/P0455 for evaporative system leaks. Each code represents a specific problem that starts small but can cause extensive damage when ignored. Invest in an inexpensive OBD2 scanner or visit auto parts stores that offer free code reading. Address problems early when repairs cost $50 instead of waiting until they become $2,000 nightmares. Timing belt failure happens without warning and can destroy interference engines instantly. When belts snap, valves and pistons collide, causing bent valves, cracked pistons, and broken camshafts that cost $2,500 to $5,000 to repair. Common vehicles with interference engines include Honda Accords and Civics from the 1990s to 2000s, Toyota 4Runner and Tacoma 5.6 models from the 1990s to 2000s, early 2000s, Subaru Outback and Legacy 2.5-liter non-turbo engines, and various Mitsubishi and Chrysler models. Replace timing belts every 60,000 to 100,000 miles according to manufacturer specifications. During replacement, also change the water pump, tensioner, and idler pulleys since you're already paying for labor. Frequent short trips prevent engines from reaching full operating temperature, causing moisture and combustion byproducts to contaminate the oil. This creates corrosive sludge that damages internal components and clogs PCV systems. Engines need to reach approximately 200 degrees Fahrenheit to burn off moisture, fuel vapors, and other contaminants. Short trips create condensation inside the engine that mixes with oil, forming milky sludge that coats internals and accelerates wear. Take your vehicle on 15 to 20-minute highway drives once or twice weekly to reach full operating temperature. This allows the oil to perform its cleaning function and prevents premature engine wear. Every vehicle has a gross vehicle weight rating that includes passengers, cargo, and fluids. Exceeding this limit stresses the engine, transmission, suspension, brakes, and frame. Overloading causes engines to run hotter, cooling systems to struggle, brakes to fade, and transmissions to overheat. Fuel economy suffers significantly when vehicles carry excessive weight or tow beyond their rated capacity. Check your door sticker for maximum payload and towing ratings. Respect these numbers to avoid premature component failure and expensive repairs. Coolant isn't a lifetime fluid, despite manufacturer claims. Even extended-life coolants become acidic after 5 years of heat cycling, corroding water pumps, seals, and head gaskets. Replace coolant every 5 years or 50,000 miles, and change the thermostat every 50,000 to 80,000 miles. This inexpensive maintenance prevents catastrophic cooling system failures that can destroy entire engines. Following these 13 habits has kept my truck running strong past 720,000 miles. They're simple, affordable practices that prevent the expensive repairs that kill most vehicles long before their time. Start implementing them today, and your engine will thank you for decades to come.